Chapter 8, Section 3 is going to be getting us into the beginning of factoring. And specifically in this section, we're going to talk about the factoring case where you have an equation that's written in the quadratic form because you have an x squared, but the number in front of x squared is just a 1. In a future section, we'll talk about what do you do if you have to factor something where there isn't a 1 in front of that x squared term. I think factoring these types of problems is probably the easiest scenario that you're going to run into because they're going to be quickly factored. You could use the approach that I'll show you in the next section when you have the number in front of x squared and still apply that same process to what we're going to do in this section. But for the purposes of this, I'm going to show you basically a shortcut that allows you to factor these types of things very quickly. So when you have something written in this form, all of your first terms are just going to have an x squared. So it's not going to say like 2x squared or 5x squared. It's just going to say x squared. Technically, there's a 1 sitting in front of that x squared, but you're never going to really see it be written unless you are putting it in there. Because most of the time, if it's just a letter, we don't put the 1 in front of it because we just kind of have the understanding that it's there. When you're factoring these types of problems, every single time what I would suggest that you do, especially as you're learning how to do this and you're not maybe as comfortable, and as you do more and more practice, this will become a lot easier for you. You may not need to do this step, but you're making basically a small t-chart, kind of like if you were going to graph something, you would make an XY chart. And on the left side, you're going to want to multiply to something, and on the right side, you're going to want to add to something. And those numbers come from the equation. So you always are going to multiply to the last number in the equation. So you're always going to multiply to that. So this one would be 10. And you're always going to add to the middle number, which would be 7. So you're going to multiply to the 10 and you're going to add to the 7 within this equation here. What I mean by that is you're looking for factors of 10 that are going to be able to do both of these things. So you're looking for two numbers that you can multiply together to get to 10. But also if you take those same two numbers and you add them, you want to get a 7. If you don't know, or if you're dealing with a number that maybe you don't know the factors as well, you can do a little bit of guessing and checking here. But the factors of 10 are kind of limited. You can either take 1 times 10, or you can take 2 times 5. Well, out of those options, I would probably grab the 2 times 5, only because when I add 2 and 5, I do get my 7. So that's going to be the one that checks. But it's okay if you guess a couple of times and you're not getting the right ones. You just want to cross it off and then move on to the next one to try again. Once you find these numbers, and sometimes I like to call them the magic numbers because they basically work the magic here. They multiply and they add to those two different numbers. Then what you're going to do is draw out 2 sets of parentheses. You're going to take that x squared and you're going to split it. So you're going to put an x in both sets of the parentheses here. And then you're going to take these two numbers, the 2 and the 5, and you're going to put those in the parentheses as well. Since both of these numbers were positive, I'm going to put plus signs in the middle. So this is going to factor to x plus 2 and then x plus 5. And this is going to be your final answer. What I have underneath here is a chart that kind of gives you an idea of what your factor signs should be depending on the situation that you have. So if everything's positive, like what we just saw up above, so you see how there's all these plus signs in between the terms, then that means that the signs in the middle of your letter and your number should be plus signs in both sets of your parentheses. Now I'm going to jump down to the last case. If they're both have minus signs, so it's like minus, minus here, they're both negative, then when you factor, you're going to have a minus sign and a plus sign. Now these middle two are a little bit different. This first one, or I should say the second one here, has a minus sign first and then a plus sign. What that means is going to happen is both of your numbers on the inside are going to have to be negative because they're going to have to multiply to a positive answer, but they're going to have to add to a negative. So you're going to have them both be negative numbers to start with. And in the last situation, if you have a plus sign first and then a minus sign, your signs are also going to be positive and negative. So kind of similar to that last situation, just different signs that you're looking at here. When you write your factors, it doesn't matter the order that you put them in the parentheses. So back up on that example, I wrote it as x plus 2 and x plus 5. I could have written it, though, as x plus 5 and x plus 2. It makes no difference the order that you put those factors into the parentheses. Okay, so I've got quite a few practice problems here within your notes on this first page. Okay, there's 1, 2, 3, 4 problems that I want you to do before the next one. The next one says example, and I want you to wait until I'm back with you explaining that. But I want you to go ahead and try to do these 4 practice problems here on your own. So I would suggest that you take a minute here, pause the video, spend some time doing those 4 problems on your own, take as much time as you need, and then come back and watch what I did and make sure that your answers match mine. Alright, so for this first one, I would have set up my chart. We want to multiply to 6. We want to add to 7. The numbers that do that are 6 and 1. So this should have factored to x plus 6 and x plus 1. For the next example, you should have multiplied to a positive 9, and you needed to add to a negative 6. Again, you could have looked up at your chart for this and matched it with one of those 4 situations. This matches the second one, which means that both of your signs here have to be negatives. So your numbers both have to be negative. The ones that work are negative 3 and negative 3. That gives you a positive 9 when you multiply, and it gives you a negative 6 when you add. So then you should have wrote that as x minus 3 times x minus 3. Now in the future, we will talk about how you could actually take this and write it as one quantity and put a little 2 on the outside corner. That only works though if the quantity on the inside is the same. So they have to be identical in order for you to be able to kind of condense it and say that you have 1 and that you're squaring it, because that means the same thing as multiplying it by itself. Okay, for these last couple here, this first one for the chart, I would have multiplied to a negative 15. And I like to put the negative numbers in parentheses sometimes just so I don't forget the negative sign in the problem. So this one matched the third case that I showed you up there, which means that one of the numbers has to be negative and one of them has to be positive. And in this case, it has to have the negative with the smaller factor. So the bigger of the 2 numbers has to be positive and the smaller number has to be negative. The numbers that work for this one are positive 5 and negative 3. So we should have done x plus 5 and then x minus 3. And for our last situation here, we should multiply to a negative 15, this time add to a negative 2. So this is almost identical to the problem that we saw up there. It's just we have 2 negative signs instead. This is that last case we talked about. This time, instead of the 3 being negative, the 5 needs to be negative. That way when I add these 2 factors together, I get that negative 2. So I would have written this x minus 5 and x plus 3. All right, taking a look here at the next example. Before we try to factor this, what I want you guys to notice is that the 27 is after the equal sign here. So the equal sign is actually kind of splitting this problem apart from each other, and we don't want that to happen when we're trying to factor. We want everything to be on the same side of the equal sign. So what we're going to do is move that 27 over to the other side, move it over to the left side so that everything's on the same side of the equal sign here. So I'm going to subtract 27 from both sides. The reason why I'm subtracting it is because 27 right now is positive, so it's got like a plus sign in front of it. So the opposite of plus would be to subtract. So now this says x squared plus 6x and then minus 27, and that equals 0. And now we're going to factor it like we were doing on the previous examples. So I'm going to set up my chart, and we're going to multiply to negative 27, and we're going to add to 6. So my numbers that I'm looking for here are going to be a positive 9 and a negative 3, because 9 times negative 3 would be negative 27, and 9 plus negative 3 would get me my 6. So then I factor this x plus 9 and x minus 3. So make sure before you start factoring, don't get too much in a rush here. Check to make sure that everything's on the same side of that equal sign. Just because a lot of times what I see maybe a mistake happen here is that students maybe mistake that equal sign for like a plus sign or even maybe a minus sign. And then they try to factor it, and you might get the numbers, but they just might have the wrong signs. So you want to really be careful and just make sure that everything is on the same side of the equal sign before you jump into actually trying to factor it. So I want you to go ahead and take a minute here and solve this one. You're going to have to rewrite it first and then factor it. Okay, so let's take a look at this example here. What I would have done first is added this 24 over to the other side. And again, I'm adding it because right now it is negative. So now it says x squared minus 10x plus 24 equals 0. Then I would have set up my t-chart. So I need to multiply to 24, add to a negative 10. And doing some work here with my numbers, I know I'm going to need them to both be negative because they have to multiply to a positive here, but I need them to add to a negative. So I found that negative 6 and negative 4 work. So I would have factored this to x minus 6, x minus 4. This next example is very similar to that in that not everything is on the same side of the equal sign. The only difference here is that instead of it being just the number, it's actually the x term. So we're still going to have to move that over to the left-hand side before we get started. So I'm going to subtract the 3x from both sides. When you do this, though, and you rewrite it, you really want to make sure that you're putting it in order. So the x squared term should go first, then the x term, so minus 3x, and then the number, so minus 70, and then equals 0. And then we're going to factor, set up our chart like we've done in the past. So I want to multiply to negative 70. I want to add to negative 3. And the two numbers that do that are negative 10 and 7. So this would factor to x minus 10 and x plus 7. Now, these do have an equal sign with 0. And I didn't really talk about this in the previous example, but what they might want you to do on a problem like this one is actually take it a step further and solve it. And what that means is that you're taking these two quantities in the parentheses and you're setting them equal to 0 individually. So x minus 10, you set that equal to 0. X plus 7, you set that equal to 0. So for this one, you want to solve for x, and you just have to add 10 over. And so that would leave you with x equals positive 10. So there would be one root. And then for the other one, you're going to subtract the 7. And that would leave you with x equals negative 7. So if a problem wants you to solve it, they'll have like equals 0 in the problem, or the directions will just say to solve. If that happens, then you're going to want to make sure that you take it this extra step and set them equal to 0 and actually state what the specific roots are. So go ahead and take a minute and do the practice problem there on your own. Okay, what I did for this one is I subtracted x on both sides, and I rewrote it so it said x squared minus x minus 20 equals 0. I set up my chart, and that involves me multiplying to a negative 20, and you had to add to a negative 1, because that's the number that sits in front of the x. The numbers that do that are negative 5 and 4. And so then this factor to x minus 5 and x plus 4. And then if we did solve it, so if we set it equal to 0, you should have gotten those both set up individually first, and then solved them, and I got 5 for one root and negative 4 for the other root.